good afternoon to all distinguished participants, both here in Geneva and online. I'll be providing an overview of the main applications of maritime communications which play a pivotal role in the daily functioning of the shipping industry and the wider maritime community. So over 80% of global trade is transported by international shipping. Ships are becoming ever more dependent on digitally integrated systems, and the shipping industry and wider maritime community are therefore reliant on communication links to navigate safely, securely, and to operate efficiently. Key communications applications include the Global Maritime Distress and Safety System, GMDSS, which is relied upon worldwide for search and rescue operations at sea. Other maritime communications applications include vessel identification tracking and security alerting systems, which enhance navigational safety, facilitate vessel traffic services, and the security of ships. In addition, terrestrial communications such as VHF, radio telephony, and satellite networks are relied upon by ships for general radio communications. So looking at the GMDSS, this is the recognized safety communication system in operation for over 25 years. The fundamental concept of the GMDSS is to provide vessels in distress with the ability to quickly alert search and rescue authorities ashore and vessels within the vicinity so that a coordinated search and rescue response can be actioned. The frequencies for the GMDSS and safety communications are contained in Appendix 15 to the radio regulations. The GMDSS, looking at an overview of the GMDSS, it comprises of interdependent terrestrial and satellite technologies and shipboard systems. It is based on the principle of 4 radio communications coverage areas, or C areas, which determine the equipment, maintenance, and operator requirements for ships. So looking at the diagram, we can see C area A1 is an area within radio telephone coverage of at least 1 VHF coast station with digital selective call alerting. C area A2 is within radio telephone of an MF coast station with the same capabilities. C area A3 is beyond areas A1 and A2 within coverage of a recognized mobile satellite service supported by a ship earth station carried on board the vessel. And then finally, C area A4 is the remaining C areas beyond satellite coverage, which may rely on HF radio communications. Following the operational procedures for distress communications, which are contained in Article 32 of the radio regulations, a ship in distress requiring immediate assistance can send a distress alert using onboard GMDSS equipment. For example, via digital selective calling on 156.525 megahertz, channel 70, which is used exclusively for distress and safety calling in the maritime VHF mobile band. The distress alert is received by a local coast station and by nearby vessels so that the necessary search and rescue response may be coordinated. Looking at some of the GMDSS shipboard equipment, it is essential that every vessel has the necessary equipment to ensure that it can establish communications with a coast station in the event of an emergency. Therefore, the specific GMDSS equipment required on board each ship is determined by the ship's area of operation. And here are some examples of shipboard GMDSS equipment, including VHF, MF, HF, terrestrial distress calling and alerting, satellite distress calling and alert capability via a recognized mobile satellite service, an emergency position indicating radio beacon or 406 megahertz EPIRB for distress alerts via the COSPAS SARSAT satellite system, an example of a NavTex receiver for the reception of maritime safety information broadcasts from coast stations, and locating signals which may be transmitted in distress situations, for example, by survival craft using a radar search and rescue transponder on 9 gigahertz, or AIS search and rescue transmitter, AIS SART, or EPIRB AIS in the VHF maritime mobile band. Other maritime radio communication applications which are not part of the GMDSS are also relied upon by the maritime industry. These include Automatic Identification System, AIS, Long Range Identification and Tracking System, LRIT, and Ship Security Alert System, SSAS. AIS provides automatic reporting between vessels and from vessels to shore. It enhances safety by automatically exchanging information such as identity, position, vessel course and speed and destination. This improves navigational safety and collision avoidance between vessels. AIS also facilitates vessel traffic monitoring and may also assist search and rescue authorities to locate vessels in distress. And we can see here a typical electronic chart display with AIS overlay, which shows AIS ship stations and their information, and AIS aids to navigation. The availability of AIS greatly improves situational awareness for vessels, particularly in areas of heavy traffic, such as busy ports. AIS search and rescue transmitters and satellite EPIRB with AIS may be used in accordance with Article 32, Provision 60 of the radio regulations. If activated, locating information, such as the position of the device is transmitted on AIS frequencies in the 161 and 162 megahertz VHF maritime bands. The transmitted information is then displayed on the AIS of vessels involved in the search and rescue. So long-range identification and tracking provides for global identification and tracking of ships to enhance security of shipping and to provide safety and for the protection of the maritime environment. LRIT is satellite-based. It also differs from AIS as the data is only available to national administrations and search and rescue authorities. So looking at the ship security alert system, this is used to transmit a security alert to shore via satellite to indicate that the security of a ship is under threat or has been compromised. Unlike a GMDSS distress alert, which is intended to be received by all possible stations, SSAS is designed to allow a covert activation to be made that alerts a competent authority ashore and does not raise the alarm on board the ship nor alert other ships. So maritime general communications is relied upon by the shipping industry, both from terrestrial and satellite systems. These are vital for day-to-day operations, for example, for voice communications using maritime VHF frequencies contained in Appendix 18 to the radio regulations, which are crucial for intership communication and port operations. UHF in the 450 to 470 megahertz band, which is used for onboard communications. And in addition, the maritime industry is becoming increasingly dependent on satellite communications for day-to-day operations, which include GMDSS recognized satellite services and Earth stations onboard vessels operating in this fixed satellite service. Several outcomes in relation to developments in the maritime sphere, several outcomes of WRC 23 support the modernization of the GMDSS and the implementation of new maritime communication technologies. These include the MFHF NAVDAT digital transmission system, which has been included as part of the GMDSS provisions of the radio regulations for broadcast of maritime safety information to ships, an automatic connection system using digital selective calling, which provides reliable connectivity to mariners, and the Beidou message service, system has been provisionally recognized as a satellite for use in the GMDSS, subject to the completion of frequency coordination and addressing interference matters. So looking at future maritime communications demand, innovation within the maritime industry is resulting in the development and of new technologies which have already seen the commercial use of small remotely operated and semi-autonomous vessels. Work is underway within the International Maritime Organization on the regulatory framework for maritime autonomous surface ships. Systems such as NAVDAT and VHF data exchange, VDES, which are provided for in the radar regulations and within ITU recommendations, may support future maritime communications developments and requirements. In terms of the development of the regulatory framework for maritime autonomous surface ships, the IMO has indicated that 2032, a mandatory code for these ships, will enter into force. These developments may drive the demand for advanced maritime communication systems. So maritime communications continue to be supported by ITU publications and information resources. It is important to recall that when a vessel, irrespective of its size or type, installs or carries maritime communications equipment, it is operating in the Maritime Mobile Service and is defined as a ship station under the radio regulations. Consequently, the provisions of the radio regulations and ITU recommendations related to ship stations are applicable to all vessels operating in the Maritime Mobile Service. The provisions of the radio regulations and associated ITUR recommendations are essential for the safety of all vessels. They enable connectivity with other maritime users, such as ships, coast stations, and search and rescue services. Therefore, administrations should implement and apply the maritime administration provisions of the radio regulations and put in place measures to ensure that all vessels under their jurisdiction comply with the relevant requirements. In addition to the radar regulations, ITU recommendations and reports, the ITU Maritime Service publications and the online Maritime Mobile Access and Retrieval System, MARS, which will be covered in detail in the next presentation, are valuable information resources which are relied upon for day-to-day maritime communications and for search and rescue operations. Thank you very much for your attention.